recording will start soon. Okay, perfect. Share my screen. So I have a couple of topics related to Databricks, Spark, and Pandas. And this one is the first one. So it is on Pandas API on Spark. Probably some of you may know it. But the reason that I brought it here is because many of us, first we learn Pandas or Python before Spark. For example, me, when I was in grad school before 7-8 years, first I was using MATLAB, then I added R. Then to learn NumPy in Python and Pandas, I was just using cheat sheet and comparing MATLAB or R with Python. That's how I learned it. Then before 5-6 years, I started learning Spark. So for many of us, we first learned Pandas. We have been using it a lot. And many of the functions, we remember them off the top of our head, and they are also short as compared to Spark. They are very succinct. But there is one limitation with Spark, with Pandas. It doesn't scale out to big data. And now we have Pandas API on Spark that handles big data also with the functions that we know, with the Pandas functions that we have been using. So that is what we are going to see today. So here are the advantages outlined here. So here a couple of advantages. If you know Pandas already, then there is no steep learning curve with Spark. You can use the same functions, the same Pandas functions to handle big data. And it is the same code also, whether you are working with big data or small data in a single machine or distributed machines. The other advantage of using Pandas API is also, as we know, something is in Spark to do it. It is somewhat complicated, or it could be long code, whereas with Pandas, it is very easy. And some of such things are plotting. So if you have a big data with a Spark data frame, now using Pandas API, you can generate plots. And the other thing that happened to us before is about running your Pandas code faster. So we had Pandas code, and the data was large volume. So we wanted to parallelize it. We experimented with Dask and also with Pandas UDF. Both of them worked, but they had their own limitations as compared to Pandas API. Now with the Pandas API, it is smoother and it is faster. Under the hood, it uses Spark, and hence it has all the Spark optimization techniques. So even if you are not running your Spark on Databricks, if you have relatively larger volume of data in your machine and running it in Pandas, if it is taking longer time, then you can use Spark with Pandas API and use all the available resources in your computer. So let's start with this information first. So Pandas API is relatively new. It works with Spark versions 3.2 and above. So in Databricks, if it's with standard runtime, it starts here, 10.4. Here it is. And also with the machine learning, we see it. So it is not this one. This version is 9.1, 7.3 long time support. They don't support Pandas API. So if you have Databricks cluster and you try this, and if it is not working, just check your runtime and change your runtime, and it will work fine. So here I'm showing benchmarking comparison of Pandas API versus Dask, because for parallelization of Python code, we have been using Dask. So how does it compare? Let's start with this one. So here, the blue color is the Pandas API. Before it got merged, it was called Koalas. So the blue color here is Pandas API, whereas orange is Dask. So you see Dask is here and here as compared to Pandas API here. So it is much faster in many cases, as you can see here. The same thing, this is filtering related. You can see that the difference is very, very clear. This part versus all these lines that we see here. So Pandas API on Spark is much faster than Dask. Plus, it has all the advantages of Spark. And since we are using Spark, it is good if we have one code base for everything that we do. So we don't need, from this perspective, we don't need to worry about using the Dask. Okay, so does anybody have any questions so far? Okay. So to import it, we just, let me see the zoom level. Yeah, okay. Let me know if you are not able to see it. So here we just import it like this. Import PySpark.pandas, like I'm importing it as PS here. Or you can import it pandas as PS from PySpark, either way. And the different functions it supports, as I can see here, just using this dir PS. So almost, except few, all of the pandas functions are supported with the API also. So you see we have like daytime, get dummies, get options, set options, is NA, is null, melting, merging, and not NA. And here also to read data, we have real CSV. So this one, it will read it as Spark data frame rather than in a distributed environment rather than just use single machine, this read CSV function. There is read CSV, read delta, read Excel, and so on, JSON, ORC, Parquet. We can read also data from databases, and we can create series and data frames. It supports strings, and also there is this data conversion. Like here we see to numeric and to datetime. All of these are the same pandas functions. And also you can set the options like what we do with pandas. Like for example, you can set the number of rows to display. Here we have display.max rows and so on. So there are differences when the pandas, when it is in a single machine, the data type is pandas.core.frame.data frame. Whereas when it is in distributed, it is PySpark.pandas.frame.data frame. So here I am reading some data from S3. The S3 is mounted, so we see a mount here, and the data is in delta format. So I am reading it using the Pandas API, as you can see, ps.read delta. Now when I check type of that, you see here it is PySpark.pandas frame.data frame. So this is delta. If you have never used delta data type before, it is a Parquet format, but it has more optimizations, and also it handles time travel, merging, and so on. It has multiple advantages as compared to using just vanilla Parquet. And if you, I will have another DS Club in coming times to go in detail about the use of delta, because I found it very interesting as compared to Parquet. These days I'm using the delta data format. But if you want to read more, in the meantime, I have added this link, 5 reasons to choose delta format on Databricks. So you can read that. So the 5 at a high level, these advantages are, as I said, there is caching, there is merging, there is time travel. You can go to a specific version in time and use that data only if you want to remove the rest and so on. So it handles time travel. Since there is caching, it is faster. You can also merge data sets like updating and inserting, like what we do with databases. So you can do that to data that exists in S3 in Parquet format. And it also has lots of optimizations. So you can read that. And here also, the delta format, since as I said, it is just Parquet using Pandas. I'm reading it using read underscore Parquet here. And I'm checking the type. As you can see, clearly this is Pandas type, whereas this one is PySpark. And we can convert from one to the other, like from Pandas to Pandas API, or from Pandas to Spark, or from Spark to Pandas API, and so on. And the functions are, there are these messages. So this one, if I just do to Pandas, then the data will be, as you can see here, now it is Pandas, even if it was here PySpark. Now when I do to Pandas, it is Pandas data type. The only thing we have to remember here is when I use this method, the data I'm collecting it from distributed fashion to a single machine. So if the data volume is very large, then I have to make sure I have enough resources in that single machine, in the driver node, if it is in Databricks, for example. And from if we have Pandas data frame, and if you want to run it in a distributed environment also, we just use this. We imported it as PS, so the PS has message from Pandas and give it the Pandas data frame. Now it is PySpark data type. And we can also convert from Spark to Pandas API and vice versa. So we just use Spark. Now it is I can use the Spark data frame functions that we have been using, or also just PySpark Spark SQL also. And now let's see more examples. Just our focus today is on the Pandas API. So let's say usually we work with Spark data frame. Then I want to perform some analysis using that data frame. I know the function is how to do it in Pandas, but I really don't know it in how to do it in Spark. Probably I have to consult the documentation, whereas with the Pandas, I remember it off the top of my head. So why should I go spend time to consulting the documentation? I can just use this Pandas API. So the Spark data frame, just convert it to Pandas API using Pandas API. Then after that, I can perform all the Pandas functions and messages that I have been using. Like here, I have examples from this down, different examples. So remember, this is PySpark data frame. I'm just checking the columns using data frame name dot columns, like what we do with Pandas. And I'm checking here also the data types, like the schema. So the column names and the data types. And as you can see, these data types are the kind of data types that we know in Pandas. There is internal data type mapping that you can see here. It is also on the website. I got it from the website. So on the left is the NumPy data types, which is in Pandas with the Pandas API also. And on the right are the Spark data types. So like float and float64 are, for example, double type. np.str, we have string type. And here on the bottom also, you see here in Pandas, it is datetime64 data type, whereas in PySpark, it is timestamp data type. But sometimes when you convert data from one format to the other, understanding how it is internally converting it could be important if you encounter some errors or if it is taking longer time. And here, the normal Pandas method head to see sample data. And the summary statistics, imagine this one, for example, to calculate these summary statistics using PySpark, it will not be as easy as this one. You see just here, it is .describe. So it gives me the mean, median, standard deviation, and the different quantiles that we know. So this is very cool, especially in exploration stage, since you want to explore things faster. knowing this, using these pandas functions helps you to be more efficient. And you don't need to use just only pandas API with pandas functions. If some of the functions you feel more comfortable using PySpark, you can integrate both of them. Sometimes you use just PySpark, in other times you use the Pandas API. They integrate very seamlessly. And I'm checking here miss values using pandas method here is null.sum per columns. It should give me which columns have missing, the count, the frequency of missing records is what I see here. Only this one has missing values, for example. This one also is like the describe, very handy as compared to using PySpark. So to get counters, we know we use value counters, or we can get it as proportions also. So just this one, dot value counters normalize true, it gives us proportions, and I can add cumulative sum to this one. It can also give me running total and so on. Whereas if it is in Spark or Spark SQL, you have to write multiple columns, maybe create a CTE or join them and so on. Whereas with this one, it is very handy. Any questions so far? Okay. So yeah, unique values that we know, unique values. I'm getting the unique values for advertiser ID here. It says if I want the count, I use any unique. Just these are, I am just reviewing the pandas functions and messages now. So any unique, it gives me 147. And if I want the unique values themselves, I just use dot unique. It gives me these are the unique values for marketplace ID, for example. So you can use in PySpark also, you can use df.select marketplace .distinct .show to show you the distinct values. The distinct.count, it will give you the count. You can also use with pandas API this way, using just unique and unique. It also supports analysis by grouping. Here, for example, I'm getting the count per group. First, I'm grouping it by advertiser ID field, and I'm getting count of budget scope ID, or I can get distinct count using any unique and so on. And the different functions that are supported, you can get it from the website. Like here, they have very nice documentation. The read CSV, read from clipboard, and also if you have Pandas API data, you want to save it to CSV, it supports to CSV also, all JSON to JSON. The ones commonly we use, you can save to Parquet or read Parquet, you can read ORC and so on. And here also the grouping, they are here, group by API supporters. I usually use these functions. There is backward field, forward field, per group apply, any, all, and also per group you can calculate summary statistics and generate plotters. You see box plot here, as a correlation and so on. This is very cool. And let's get back to here. Here I am dropping duplicators also. Yes, using drop duplicators. Per group I am calculating here mean, just after group by this advertiser ID. I have budget column, which is numeric, and I'm calculating the mean per advertiser ID, for example. Filtering also, the normal pandas filtering that we know, it supports that. Here you see I'm using square bracket, this PySpark data frame name, and I have a column called marketplace ID. So I'm excluding this marketplace, just like what we use with pandas, and I'm checking the number of records remaining now just using ship. It supports also the .str accessor and .dt accessor. So the str accessor, we use it for processing string, like for example, if it contains to filter if a specific column contains some characters, if it ends with some characters, if it started with some characters, or we can also pass a regex to it, regular expression. So this advertiser ID is a string. So I'm filtering where the advertiser ID contains this string. So this is nice. That still contains this one. With DT also, with a DT accessor, this it handles daytime. Now I don't have month column, but I want to filter the data for the month of September. So I'm creating the months using this DT accessor. This usage update timestamp tool is daytime field. So I just use DT months equals to 9. So this filter is now only for September, and I'm checking here if the month is only September. And also you can convert it to NumPy if for some reason you want to convert your final output to NumPy and process, either display it or further process it with NumPy. Also, as you can see, it supports this to NumPy method also. So .str accessor and .tt accessor are very useful, as we know. And there is transform and apply. You can apply any kind of function here with transform and apply. The difference between transform and apply, transform returns the same number of rows as the input data frame, whereas with apply it is not necessarily the case. Yeah, there are examples here in the documentation. You can read that, like for example here, just adding to the existing values, it is adding 1. So you see 1, 2, 3, no, okay, 1, 2, 3, 4, 5, 6, and where is the output? Okay, the output is not displayed here, I guess. But we can't just transform it like that. So transform and apply is these functions are very useful because you can apply your custom functions if there are no handy functions, or if there are no methods that support your kind of analysis, you can write your own function or use NumPy functions. Like here, for example, I am using np.cumsum to get cumulative sum using this function from NumPy. The other advantage, the main advantage we said, is about plotting. So plotting with Spark data frame is not easy, but with Pandas API now, you use the same plotting functionality that you use with Pandas. So here, for example, what am I doing? I'm grouping by marketplace ID and getting the mean of the budget and creating a pie chart of the mean of the budget. So I want to see per marketplace ID the mean of the budget. So this is a pie chart. There is one marketplace ID that accounts for 99.4%, and there is very small contribution are here. But this is very handy for plotting that we use with Pandas. And here I'm creating a horizontal bar graphs. The same thing, group by budget scope ID, get the budget, mean of it. So sort values in descending order. I want to get the top 10 and chain it using just .plot, .bar h. So it generates this horizontal bar graph. It handles lots of different plotters. And here also I'm using the DT accessor to add a column. You can add column just like using square brackets, like what we do with Pandas. And I have added hour here. Then I can group by hour and get the mean of the budget by hour and generate a vertical bar graphs here using just .plot, .bar. Using this, I just need to add this part to generate the plotters. So that is really cool. And yeah, you can see the supported messages, different supported messages using dir. For example, once I group by hour, now I want to do analysis on budget. What are the different supported messages? Or if I forget what it was, I just wrap it in dir then it will show me all of them here. So you can see forward field, field in A per group, maximum, median, mean, n largest, n smallest, rolling, shift, size, and all of them. So these are some of the nice functionalities of using Pandas API on Spark. So as I said, this is useful for integrating. If you feel comfortable, like for example, I have been using Spark for 5-6 years, but still with some functions, I feel more comfortable, or I easily remember the functions with Pandas. So now this gives me the opportunity to integrate both of them and get results quickly, especially when I am doing data exploration. And I have added references here. I think today's content is short relatively, but it is useful if you have not used Pandas API before. I encourage you to explore it, and I'm sure you will love it.
Awesome. Thank you.
Sure. Any questions?
I have a few comments. I should mention. So I agree with you. I think this new API is a game changer. I really like it. I have noticed you do have to be careful, and when you're going to the PySpark Pandas API, go to the Pandas API and make sure that they really are one-to-one. I found that in a few cases they're not perfect, and you have to be extremely careful about just doing that translation. So one off the top of the head example is the date time deltas. They really aren't implemented in the Pandas PySpark API, so you have to kind of just resort to using just Pandas. But a few other of the built-in methods that are supported by Pandas PySpark API that are Pandas-like methods have slightly different arguments, or don't have the same list of arguments. They may have like 4 of the 6 or so forth. So yeah, it's definitely something you should still be being careful about when you're just, let's say, writing Pandas code and then thinking it will port over to Databricks easily.
Good, yeah, thank you. How common is that? Like, how many such issues did you encounter so far?
Well, I'm very, I can't say exactly how many. It was definitely a handful. It wasn't uncommon.
Mm-hmm.
So I was very particular about making sure, just because new technologies I don't trust. So I had both the APIs back up and back to back look while I was testing out this new API. So it's there. It's definitely there. A lot of the basic ones you won't ever encounter issues with, but if you're doing slightly more sophisticated things, it's going to come up more often than you would think.
Perfect. Okay. Thank you for letting us know that.
Yeah.
Good. Any other comments or questions? Perfect. So I will share the notebook if you want to explore, and also the documentation is enough. It is good documentation, so you can spend the time and explore it.
Cool. Thank you.
Perfect. Thank you so much, guys.
Thanks, Fish.
Thank you, Fish.
Bye.
Thank you.
Thanks, Fish.
Everybody.